what we decided to cover today is a classic crossover topic between database administrators and developers, which is why I very much wanted Gary to be on the line as well with me for this, because when it comes to using hints in your code, you can get a bit of a dispute between the developer's approach and database administrator's approach. When you should use them, when should you use them? Should you use them at all? And we'll have a bit of discussion about that coming up shortly. Of course, we'll look at the syntax for using hints, and then we move on to the hints that everyone should know. There are a small number of hints. You don't need many. There are a small number of hints that all developers and DBAs really should be familiar with. There are, of course, any number of hints that are less frequently used, that are very important indeed. And there are any number of hints that are not documented, that are deprecated. There are hundreds of hints kicking around. You don't normally need to use very many. Some would say you don't ever need to use any. But there are a few we should all be familiar with, and we need to be aware of a few more as well. Then we'll finish off with a topic that's sometimes of burning interest to developers. Why are my hints being ignored? Never mind why you've decided to use them, but for whatever reason, you've decided to pepper your code with hints, and the hints just aren't being used. Why not? That can be so frustrating. So that's my agenda for today.
John, could I throw in a question here?
Of course.
You mentioned that some are documented, some are not. Where are these hints documented, and how do the non-documented hints come into circulation? Are they only for the guys in white coats? And it seems a bit of a mystery.
It certainly does. The official documentation for the hints is in the SQL reference. SQL reference, if I remember correctly, is buried in the the SQL reference in the select statement. There is now a SQL tuning guide and maybe some documentation on that as well. But what about the undocumented ones? Well, for example, a hint I was using just the other day is the ordered predicate hint. The ordered predicate hint. If you have a query and in your where clause you've got two filters, which filter will Oracle apply first? Well, Uncle Oracle will decide. But there may be occasions when you don't want Oracle to decide which filter to apply first, because you know deep down inside that you want that particular filter applied first, perhaps because if a parameter, if it gets a null or something, there's going to be an Aura 600. You might have a reason for wanting filters to be applied in a particular sequence. There is a hint, ordered predicates. The ordered predicate hint still exists, still works. It was documented up to and including, if I remember correctly, release 10, but is now deprecated. So some undocumented hints, maybe you have to trawl back through the documentation to find them. Ordered predicates can be quite useful, but not documented for several years now. And others, of course, are documented, if you call it documentation, in Metalink or Moss articles. And any number, of course, Google around, and you'll find all sorts of information about them, which may be correct, it may be complete rubbish. But you'll find on numerous websites people describing the effects of certain hints. How accurate are they? Well, do your own reverse engineering, and maybe you'll be able to work that out. So official documentation, yes, it is there, but some of the others you'll have to do some research. Now, when should hints be used? This first bullet point is a DBA's answer. Never. Well, that may be a bit draconian. What I want to say, though, is that some sites have rules about hints and others don't. And at one extreme, hints may indeed be banned completely. If that is the case, you can, in fact, force it. In the current release of the database, we've got these instance parameters. Optimize to ignore hints, optimize to ignore parallel hints. These are very recent parameters, only came in the last couple of releases. And at last, the DBA, by setting these parameters, can control hints inserted in code perhaps by developers or end users, that he has no idea about. So it is now possible to stop hints from coming into effect. And these are second level parameters or instance level parameters. So you can stop hints running. You can have a rule you should never use hints. Well, why might that be? Well, for example, hints can cause problems. A hint is an instruction to the optimizer on how to run your code. A hint that fixes an issue in one release of the database might break something following your next upgrade. Hints, particularly the uncommon or undocumented hints, can have weird side effects. Now, a hint that was needed, perhaps it was even inserted in your code on the instructions of support. So that hint maybe was really needed years ago. A classic case for that might be a hint that prevents the optimizer from developing a plan that is known to cause problems. Some SQL statements might fail with certain execution plans, or a 600 perhaps. So you put in a hint to block that execution plan. Okay, you need it, but perhaps that's now been fixed, maybe even just with the next release update. And that hint should then be removed because it might be slowing things down now. So hints that maybe were needed, perhaps aren't needed anymore and could even be causing problems. And that comes to, but on the other hand, there are times when you've got no alternative. And that's probably leads one on to a sensible policy to permit hints, but document them. Now, the problem you get is that perhaps a hint was inserted years ago, no one dares remove it because they can't remember what it was for. So document your hints whenever you use them, and with every upgrade, revisit them and see if the hint is still relevant, still needed. That, of course, is production code. In development environments, I use hints all the time, to experiment with different execution plans, test various possibilities, see if performance can be improved. So in production code, production environments, be very careful. In development, sure, use them as much as you wish. That having been said, there is one class of hints that many sites will permit without any debate at all. And that's hints that tell the optimizer how you wanted it to behave. So you tell the optimizer what you want it to achieve, not how it should actually do it. And these are the three categories I put here. There may be more. Optimizer mode, parallelism hints, and perhaps in a distributed environment, driving query hints. For example, I'm working, by the way, just in the usual demonstration schemas here. If we were to run a simple query and get an execution plan out, let us try. I'll enable the auto trace facility and a simple query. Select star from emp, join dept using deptno. Can't get simpler than that. And back come the 14 rows. So that was my query. 14 rows come back, and you can see what Oracle decided to do. Oracle decided to execute that statement with a hash join at dept to emp. Now, the hash join costed us 6. It can be very fast, but there's a delay before it starts returning rows because the first row set, the build table, to use the official term, the first row set must be prepared completely as a memory structure. Only when that has been done can the second child of the join start to execute, which is the scan of emp. So you issue your query, your statement, and then you're sitting staring at nothing while that goes on. Only when that is completed does that start. Then the rows will come back really quickly. Now, why has Oracle chosen this? Because of this. Optimizer mode. The optimizer mode parameter defaults to all rows. That instructs the optimizer to generate plans that will run a query to completion as fast as possible. But you don't always want that. If the application involves human beings, maybe it's a form in a web application perhaps, what would happen with all rows? Well, while this is running, you're staring at a blank screen. And then suddenly, bam, all the rows appear. That's not a very nice user interface, is it? So maybe we should use a hint, such as this. Select /star plus first rows. from emp join depth. I'm playing games with the optimizer here, by the way, and the optimizer is cleverer than me. So some of these demonstrations may give some slightly unexpected results. But anyway, having put that hint in, we get a very different plan. We get a nested loop join of emp index access. Sure, the cost is now 17, whereas previously the cost was 6. But the difference, as far as the end users are concerned, may be a great improvement, because the looping structure, which is iterative, is going to send rows back much faster. As we scan emp, we get the first row of emp, Mr. Smith. We use his department number to probe that index. We use the row ID retrieved to get the row from depth. We do the join, and we send the statement back. We send the row back for display. Then we get the second row from emp. We use his department number to probe the index, join to the right row, send the row back. So the end user is getting data back on his screen much, much faster, even though overall the statement might take a bit longer.
John,
that's a fine hint. Yes.
Is there any difference if you use the number of rows in the
Oh, right. Yes, you can use first rows and then apply a number to it. Personally, I don't think there's any difference. I've never seen any significant difference in execution plans. That having been said, if your application has a window that shows 15 rows, okay, give it first rows 15. Now, I'm not convinced that that makes much difference myself, but try it and let me know.
Okay.
Yeah. In general, though, this is a fine hint, because I'm telling the optimizer to tune for an interactive application, not for a batch process. Perfectly valid. I'm telling the optimizer what I want to achieve. I'm not telling it how to do it. Another one, parallelism. Maybe, for whatever reason, maybe I want to run this query as fast as possible. Okay, I'll give it a parallel hint. And there we see we've got, let's see, that scan of emp, parallel combined with parent. Yeah, so the hash join is now implemented with parallel query. Is that good or bad? Well, it's what I want to achieve. And your DBA, by the way, will have strong opinions on use of parallelism. But if you know that a query should have extra resources, okay, give it to them. Like that. Remember, parallel query does not scale by design. This is intended to take up all the resources of the machine, all the CPU, all the I/O capability. It does not scale. But then if you know that that's what you want for this query, okay, hint it, good enough. Lastly, we've got distributed query, driving sites. Again, if you've got your joining to tables through database links, Oracle has no idea, the optimizer that's parsing a statement has no idea of the state of the database, of the state of the data in a remote database. And by default, it will choose to copy all the data to your local database and do the work there. That might be a bad decision. I'm going to be fairly quick at this stage, by the way. But for example, if I create a database link, you'll see the effects. Create a database link. And if I then run a query through it, my query here is I'm joining, select ename dname grade from emp at L1, my remote database, join to dept at L1, join to salgrade, which is local. So I'm joining emp to dept to salgrade. And what Oracle has done is it has copied the entire emp table to my local database through the link. It's copied the entire dept table through the database link. Is that sensible? It might be monumentally stupid. It's using a merge join. Well, its options are strictly limited. If I happen to know that it would be better to join emp to dept at the remote site, these are bigger tables than salgrade. It would make a lot of sense to join these to the remote site and just send the small table to the remote site. But if I know that, I can do it. Like this. Driving site. And now we see the plan developed, which is seen from the point of view of the driving site. We are now joining dept to emp locally, and then we do the join to salgrade. And so in that little table, and note you see, no idea how many rows are in it, but accurate estimates here. And that's the small table being sent across the link, remote to serial. Whereas previously, you can see Oracle had no idea how big EMP was, no idea how big depth was, but he did know how big salgrade was. So in some cases, these are perfectly valid hints. But then, when else do you use them? When there's absolutely no alternative to get your code to run. And speaking of alternatives...
Pardon me, John.
Yes.
Will you be talking at all about the parallel hints?
I don't think so. We can if we have time. All I really wanted to do at this point was introduce the parallel hint as being, this is a hint that talk about it with your DBA, most definitely. And if between developers and DBAs, they decide that this query really should be able to take up the entire machine resources, possibly destroying performance for everybody else, okay, use it.
Right. So if there's time at the end, I'll throw a question about the difference between some of the parallel hints to you.
Okay. Alternatives to hints. There are quite a few. You have to ask the question, why did you not get the execution plan that you want? Because you're deciding that you are cleverer than Oracle's cost-based optimizer. When we were doing some preparation for this webinar, Gary and I were talking about when the CBO first came in. I'm afraid we're both really old men. And back in release 7, when the cost-based optimizer first came in, we were all used to using the rule-based optimizer. And we all said cost-based optimizer is rubbish, right? Well, it wasn't. It was the way we administered the databases and wrote the code that was the problem. And as I've become less of a hacker and more of an Oracle scientist, I've realized increasingly that when the cost-based optimizer gets it wrong, it's very often my fault. And these are some of the reasons. Why didn't I get the plan I wanted? Why did hinting a different plan run better? Why did Oracle get it wrong? One common reason, statistics. I think we've got a couple of webinars around about statistics, webinars and online tutorials, particularly about extensions and column group statistics and so on. But your statistics may not be adequate. They may be missing, they may be inadequate, they may be inaccurate, particularly when you think about extensions and histograms. Maybe you need more statistics. Right. I'm just going to gather statistics for my site here to make sure I get some decent figures. You notice I'm relying on dynamic sampling at this point because I don't have decent statistics. So I'm just going to gather some now, and I'll analyze my Scott schema, and I'm going to build up histograms on all the columns that have a skew. Now, take an example. What if I run a query such as this? Select star from AMP, where depth no is 30, job is salesman. Easy enough. There are 4 salesmen in department 30. But, oh dear, Oracle thinks there's only 1. Classic problem here. Oracle has underestimated the cardinality. Multiply this up to the real world, Oracle might expect 100 rows and get 100,000. It's a disaster. And that's going to reflect in bad join orders, bad join methods, bad access methods. And it's my fault, or your DBA's fault, for having bad statistics. The hacker's solution, by the way, is this. Raise my dynamic sampling level to 4. And now when I run the query, hey, perfect estimate for the 4 rows. That, of course, is the hacker's solution. The real solution is to create a column group extension. So we do have a few tutorials around that. Now, statistics, major problem. SQL context, SQL syntax. Maybe the way the SQL is designed is causing an issue. For example, take a query like this. Many developers like to do this sort of thing. They project a subquery. Right. But what I'm doing here is, let's run that. I've now got department name and employee name. And if you look at what Oracle has done, it's a pretty nasty plan. There's the scan of EMP. There's the subquery. That's the subquery. This is select dname from depth. There. And that's being iterated in the worst case, because there are 14 rows in EMP. In the worst case, that will be run 14 times. This is a correlation that's pretty nasty for Oracle to deal with, projecting a subquery like that. Right. If I were to rewrite it as a join, it would usually be much more efficient. For example, rewrite it as left outer join. It have to be an outer join in case there's an employee with no department. And there we see outer join will usually be much more efficient because it isn't iterative. Whereas this structure, that gets iterated for every department number found in that table. So the SQL syntax can produce a very different plan. Constraints, or not enough constraints, also can cause problems. I won't go through too many demonstrations. Indexing and partitioning, dramatic effects there. If your indexing and partitioning strategy are not appropriate, you will get bad plans. If whatever you do, you still can't get the plan you want, baselines and stored outlines. Well, stored outlines are now pretty much deprecated in the latest release. You are allowed to use baselines, even in standard edition, in the current release, but with somewhat limited functionality. But baselines and stored outlines will let you, to a large extent, freeze execution plans. Get a plan you want and use a baseline or stored outline to nail it down. Profiles, if you have the tuning pack, SQL profiles can be a workaround for the optimizer getting it wrong. Or in the later release, of course, you've got directives. I know SQL directives have had a bit of bad press recently. They only came in 12C release 1, and have quite a bit of a reputation for causing problems. I noticed they are by default not enabled in the current release. But these techniques, again, will allow you to affect the runtime, the running of your code without the need for hints. And the big takeaway from this slide is meant to be that hints are an absolute last resort, to be used, in my opinion, to be used only when all else has failed. And we'll look at using them just after a short break.
Thanks, John. We provide database administration services led up by John. So if you call us, a project that we can help you with, we'll put John on the case for you. So it could be anything from implementing new servers, bare metal up or on the cloud, or a simple tuning task. Maybe you have an application or some SQL that is old and complex or new and complex and is not performing, meeting your criteria, and we can certainly help with that. We also write Apex applications, design and develop Apex applications either as part of a team or we'll take on the entire project for you. The teaching and mentoring is a big part of our business, and we do have a SQL tuning class that is coming up on August 23rd. So these are online classes, instructor-led, hands-on. So a good opportunity to learn from John how to tune SQL in an Oracle database. And as far as tuning the database itself, we do have a database performance tuning class running on September 20th. Also, of course, taught by John. All of these classes are taught by John. And last but not least, in the upcoming database classes, we have the Oracle DBA2 class coming up on November 1st. We also, last but not least, we also provide Apex in the cloud hosting. This is a fully managed hosting service. So for those of you who are overloaded as far as DBA capability goes, we can handle that for you. We'll put it in the AWS cloud or the Oracle cloud, provision your environment for you, set up Oracle database, and get your Apex stack up and running. And you concentrate on the applications, we'll concentrate on the platform. If we can help you, please keep us in mind. We do appreciate it. Back to you, John. Thanks very much.
Let's move on to using hints. I've spent enough time trying to persuade you not to. So, just a very brief point about the syntax. If any of you are not familiar with hints, the syntax is dead straightforward. Consider this. If I select empno from emp, right, back come my employee numbers, and Oracle has done this for the index full scan. The reason it can do it is because that column is declared not null, and it's indexed. So a not nullable column with an index, Oracle is fully aware that it's probably quicker to scan the index than to go to the table. Okay, hint syntax. Immediately following the verb, the select in this case, slash star plus, then the hint. In this case, I might full emp star slash. So it's just a comment. Yeah, slash star. A normal comment would be slash star, any old text, star slash. Oracle proprietary syntax, the plus symbol. And that tells the optimizer that this is a hint, not a comment. And doing that, it's now doing a full table scan. And you can actually see the cost has gone up significantly. The other syntax is to use the hyphen hyphen plus at the end of the line. So that will be select and then the plus, and then give it the hint. And then, of course, on a separate line, continue the statement. And there we go. So full scan because I hinted it that way. I always use the first syntax, always, but that's just because it was the first one I learned. Note that the use of table aliases, that catches everybody out. Let's just say I use e.empno from emp aliased z, and I'm getting an index full scan, of course. And if for some bizarre reason I want to do a table scan instead, slash star plus full emp, close the hint, and I got a full scan. But I hinted, sorry, I got an index full scan, but I hinted it to do a full scan of emp. What's that about? Well, the latest release of the database, Autotrace or Explain Plan, includes what they call a hint report. And what we're seeing here is there was one hint which was unresolved. And that was that hint to do a full scan of emp. Unresolved. I told it to do a full scan of the emp table. It doesn't know what the emp table is. That's because of the alias. So never forget that. Syntactically, if you are aliasing your row sources, then you must use the alias in the hint, like so. And now we see the hint has come into effect. So this hint report is a bit confusing in some cases, but it's very, very useful indeed. So be consistent in the use of table aliases. You can put hints in outer queries or in subqueries. Views require a particular mention. Now, as a general rule, you can put hints in subqueries. You can put hints in views. Please don't. Well, in a subquery, sure. And in line view, sure, put a hint in if you must. But please don't put hints in your stored views and your compiled views. The issue is that when you create the view with a hint, you create it and you put the hint in and you've got a good reason to. But the trouble is you don't know how I am going to use your view. You don't know what filters I'm going to apply to the view. You don't know what tables I'm going to join it to. So your hint may work well when the view is used as you expect, but it may be disastrous when it's used by your users in a different way. So if you must hint your views, how do you do it? Well, let's take a simple example here. I'm going to create a view that will show employees with their salary grade. Remember the tables? Each employee has a salary, and then we've got the sal grade table that says if your salary is in a certain range, you are a certain grade. So my view is going to be this. Create view E grade as select E name, depth no sal grade from emp join sal grade on sal between low sal and high sal. Right. So there's my view. And if we run it, what does Oracle want to do? There we see the detail with the grade, and it's doing a merge join of sal grade to emp. Right. So straightforward enough. Maybe, notice starting with sal grade. Maybe for some reason, can't think what it would be in this case, I want to change the join order. Perhaps for whatever reason, I want it to address emp first. The syntax is slightly odd, but it's an extended syntax. The extended syntax to let you push a hint into a view. So rather than embedding a hint into the view creation statement, so I could hint this select statement here to say start with emp. rather than with sal grade. Don't do that. Do it like this. Use the leading hint. The leading hint controls join order. And there's the syntax from eGrade dot emp. So a dot notation to push the hint into the view. And now when I run the view, remember previously it was sal grade first, then emp, but now pushing that hint into the eGrade view, and we're now starting with emp. So don't hint your views in their view definition, hint them by pushing the hint in from outside. Now, which hints should we be using? Which hints should we all know? I'm just going to begin. I'm going to go to a different schema. I'm going to connect the SH schema, which is a bit more complex than Scott. And here's my query. So I'm going to use for a couple of examples. I'm summing up amounts sold from the sales table, joining to customers, countries, products, times, channels. And remember, customers, products, times, and channels are dimensions of the sales facts table. Countries is going one further out on the customer's dimension. And my filter predicates here, country, Europe, product category electronics, channel direct sales, Sunday, and then times, Sundays in August. This is classic data warehouse stuff. I'm asking whether people in Europe buy electronics in shops on Sundays in summer. So I'm counting the facts while filtering on non-key columns to work out maybe should I open the shops or not. Right. Ooh. Set auto trace on explain and try again. And there we go. So we sold that much, it seems, to Europeans on Sundays in August. And there's the execution plan. Right. Now, join order. And the join order for this statement, we've got a few tutorials on reading execution plans. But what's happening here is our join order. Let's see. Yes, we are beginning with times and joining to sales via a bitmap index. So our join order is times to sales. Then we're joining back to products, to channels, and then to customers, and finally out to countries. So we're starting with times, joining to sales, and countries is coming last. Now, channels, for example. Channels is a small table, and Oracle thinks we're only getting one row from it. So you think, hey, aren't you meant to join small to large? You know, why am I starting with channel? Why am I starting with times where I'm getting 22 rows? But I should be starting with channels where I get only one. Well, never mind the detail as to why. It's to do with the filtered rows percentage. But maybe you want to experiment with a different join order. Okay, this is where you do it with a hint. And what I shall do is insert, make that a bit bigger, format, font, push it up to there, say. Right. And I shall insert a hint. And the hint I'm going to put in is the leading hint. The leading hint is the silver bullet of SQL tuning. Get the join order right. Note the use of the alias for the channels. So I'm telling Oracle, when you run this statement, instead of starting with times and joining to sales, I want you to start with channels instead. Right. Try it. Oops, did that save? Oh, there we go. Leading channels and run. And now you see, ooh, a hash join. We're actually now starting, yes, we're starting here. We're joining channels to sales. So we're joining channels to sales, and only after that are we going to times. So I've got the new join order. And in fact, the cost is now 902, whereas previously the cost was 588. So the cost has gone up by changing the join order. You can't direct, it isn't really fair to do direct comparisons of cost, but the implication is that I've actually slowed down my query by going for a different join order. Why? Well, you notice that previously I had an index access path into sales via that bitmap index. Now I'm actually doing a full scan of sales, so which is costed at a rather higher price than it was previously. So for whatever reason, the cost has gone up, but that's an example of the leading. It's the silver bullet of tuning. If you get the join order right, you're probably okay. Yes.
Is it a guarantee that if the cost goes up, that the response time or elapsed time will go up?
No, it isn't. You've got to test it with timings. There could be so much going on in the background. For example, this is a full table scan, and that's about half of the total cost. A full table scan, that can be done with multi-block reads direct to PGA, whereas the index access would be indirect reads via cache. You know, there's a lot going on. Just because the cost has increased doesn't necessarily mean it's slower. It's a big hint that probably is, but you always have to do your reality checks.
Tell us the difference between parallel auto, and parallel some specific number. Is there a performance difference between those hints, John?
There might very much be. It depends on your environment. With parallelism, if you know what you're doing, you can tell Oracle what degree of parallelism to use. If you know your environment, your queries, the affection of the users, you can hard code degrees of parallelism. If you use automatic parallel tuning, you're trusting Uncle Oracle to sort it out for you. Theoretically, the automatic algorithms will give a better result because they're dynamic. Yeah, it might be that when the database is very busy, the automatic algorithms will run your query with a degree of 4. And when the database is almost idle, it'll run your query with a degree of 32. You know, so you should get that versatility with the automatic algorithms. Whereas if you hard code parallelism in your statements, it's always going to do that whether the environment is right or not.
Right. Yeah, and I might say, you know, the environment can change, and what we're talking about is CPU cores and threads and stuff. The environment could change, and therefore the auto would adapt. So specifying a specific number might not be the best choice for future.
So I've hinted leading, that's the hint everyone should know, to force a join order. And it's changed a few other things. For example, we've now got a hash join. Well, we're now starting with channels going to sales. Without that hint, what else do we need to use? We need to control the join method. Right, I'll remove that hint. I'll just remove the plus, that will make an ordinary comment. And what Oracle wants to do is join times to sales using a nested loop. Well, I say, these are big tables. For big tables, we should use hash join, shouldn't we? Okay, test it with a hint. So, and what I shall do is hint the use of a hash join. And that will be just use hash when you get to sales as the probing table in a hash join. So we test that. The use hash hint to force a join method. Oops. And we are now using hash join. We're actually using a Bloom filter, it's quite clever. So previously, we were using a loop join of times to sales. Now we are using a hash join of times to sales, and the cost has gone up to 900. Looks like a bad decision again, but who knows? Parallelism might help with that, because they are big tables. The conclusion? Well, probably the optimizer got it right in the first place. The final hint we need to use, though, is access method. So join order, the leading hint, join method, use hash in my example, or use NL for force nested loop. Access method, that's indexes. My original plan used an index to get to sales, didn't it? Well, maybe, whereas now we're using a full scan. Well, let's try use of an index. And this is where we can begin to stack the hints up. Oops. Right, I've told it to use a hash join, but it's no longer using an index. Okay, let's tell it to use an index. And that says use any index in any way to get to sales. What happens now? Right, we've got the hash join, and we are now using an index. It's chosen an index on a totally different dimension. So it is using an index. This is an example of a horrific side effect. I'm using an index, but look at what's happened to the cost. It's gone through the roof. Because for a hash join, to use an index is totally ludicrous. And the optimizer knew that. So nice example of some odd side effects. So those are the hints we need to be aware of. Everybody needs to know about join order, how to hint or force a join order, the leading hint, join method, use hash or use the other join methods, access method, use or don't use indexes or scans. There are some other ones that we need to use, cardinality information. For example, I'm just going to get rid of that hint, like so. So what Oracle wants to do is times to sales loop join via an index. But look here, products. It thinks that there are 13 electronics products. Remember my filter? Product category electronics. Oracle thinks there are only 13 of them. What would happen if my company expands? If I become Amazon and all of a sudden I don't have 13 electronics products, I've got thousands and thousands. Very useful hint we need to know about that, to tell it that we've got more, what if instead of 13 electronics products, what if we had several thousand? Handy hint for that. And the hint is opt estimate. This is another one you'll need to look up. Opt estimate. I'm going to tell it that for the table PR being the alias for products, for that table, PR, the number of rows flowing into the query, rows equals 10,000. What would happen if I had 10,000 electronics products? Very useful way of testing things. Save that.
John, I think you've got a typo in there.
Ooh. I think I have to. Thank you. Right. There we go. Right. That's more like it. Right. And now we get a completely different plan. You can see here, it's now expecting 10,000 electronics. And the join order has indeed changed. Previously, we were going times to sales, then to products. Now we are going, now it knows there's a lot more products there. We're going times to sales, to customers, to channels, and then out to, customer times to, we're going times to sales, then, channels, countries, customers, and only the very last step are we hitting products. Useful hint that. Parallelism we've already talked about. Whether you should or shouldn't merge views and subqueries, whether you should materialize them. I'm keeping an eye on the time here, but I think we can perhaps do this one.
We've got some questions in the queue as well.
Okay, let's pick them up now.
Right. Tori is saying that there are times when oftentimes that they're seeing the optimizer is choosing a hash or a merge join, but he's seeing that it's faster to use nested loops with indexes. Might you know a reason the optimizer is leaning towards hash or merge?
Could be something like system statistics. Remember, hash joins and merge joins can be done with multi-block reads, whereas index access is single block reads. It could be that your system statistics are off, for example, and it's making a mistake for that reason. It could be that the cardinality estimates are completely wrong. And that could be why it's making the wrong decision. There could be many, many reasons. And it all goes back to, why did the optimizer make a mistake? Why did it get it wrong?
Great. So the parallel append hint using inserting, but there's now a concern based on the parallel hints don't scale. But isn't the parallel hint append hint a little different for direct path reads?
And the append hint, that's a hint that if you and your DBA decide to use an append, sure, you can use it. And you've got all the problems of locking involved, for instance. You're going to need a good reason to use an append hint. But yes, the append hint, particularly combined with parallelism, can be very, very fast indeed. It's got drawbacks, but if the drawbacks are not as important as the speed for that one statement, remember, you're tuning one statement at the expense of everything else, go for it.
Cool. Are there times when CBO will refuse the hash join?
Well, it can't do it, for instance, if your join predicate has to be equality. You cannot use a hash join because of the way hashing works. It has to be an equality join predicate. The example I gave earlier of a join from emp to cell grade using a between, you could hint hash join until the cows come home, and Oracle can't do it. So there will be times when hash join is simply not possible. Outer joins have limitations as well, and that's where constraints can come in, because of forcing a join order. So there could be times it won't work, when it simply isn't possible.
What are your thoughts on ordered versus leading?
Ordered is ancient history. Ordered will join all the tables in the order specified. So if your query is joining 20 tables, you're specifying complete join order for all 20. Whereas leading, you can nominate just one, or maybe the first 2 or 3. And that gives the optimizer free rein to order the remaining ones. So generally speaking, I would always favor leading. You might be able to outguess the optimizer for 1 or 2 tables. You're not going to be able to outguess it for all 20.
Cool. So if statistics are updated, should we still, or would we still need the opt estimate hint?
You could adjust the statistics instead, but remember the hint I'm using here is telling it how many rows will flow into the query after applying the filters. So just adjusting the stats, you'd have to do a lot of work on hacking the histograms as well. But that would certainly be an alternative approach.
And last, how do we know if we had bad statistics?
Because the estimates are wrong. This, for example, is saying we are expecting to get, what's a suitable example? We are thinking that there are 22 rows in the times table for August on Sunday. So you simply run select count star from times, where calendar month name equals August and day name equals Sunday, and see if you get 22 rows back. And if you do, the statistics are good. And if you don't, they're bad. You break down the query and do the count to do the test.
Yeah, brilliant. Brilliant. Seems so simple when you say it, John.
Well, let's skip over
back to
why hints don't always work. Right. Syntax, I've given a couple of examples. Join orders may mean hints can't work. As an example, if I go back to I'll go back to Scott and set auto trace on explain. So as an example, simple query such as, let's see, and we've already seen a couple of syntax examples. Join orders can totally confuse things. As an example, let us say I begin by running a simple join of emp to dept. Okay, merge join. I wasn't actually expecting. Anyway, we've got a merge join. I wasn't expecting that, but I'm sure we can work with it anyway. Oh, I know why. It's because of these statistics I installed. I gathered stats, didn't I? Let me just execute stats dot delete schema stats for my schema and spelling. Right, that should put me back to dynamic sampling. Right, so dynamic sampling had chosen a hash join of dept to emp with dynamic stats. Right. Maybe I try to think, I don't want a hash join. I want to do something else. And you could try, for example, to /star+. Let's use a loop join instead. Use a nested loop. And I'm going to say use nested loop for D, dept. Hasn't done it. Okay. There's my hint, and it's been ignored. Unused. It just ignored the hint completely. And that's massive join order. What this hint says is use a nested loop when you get to D as the second table in the join, or actually getting to D as the first table in the join. So the hint doesn't apply. Right. Whereas I could say E with a nested loop. That hasn't worked either. It's getting worse. Again, now because join order. it's now chosen to start with emp because it really doesn't want that hint. So to get what I want, I'm going to have to force leading D. And now I should get the plan I'm looking for. Nested loop. And this is where you can go down a rabbit hole of hint after hint after hint after hint to get the result you want. And that was all caused by inappropriate join. The hint didn't match the join order. Constraints. If the constraints mean you can't rely on things, if I create index name I on emp ename, remember I said this before our break, constraints are vital. If I index that, and I select ename from emp, this will be the last demo I'll do, by the way. It's doing a table scan. Okay, tell it to use the index, the hint, an access method hint that everybody should know. I want you to use an index when you get, I want you to use the index name I. And it won't do it. Unused. And that's because of a constraint. If I alter table emp, modify, ename not null. There are other techniques as well. But if I do that, then we should find that all of a sudden, magically, the index is usable. Right. So constraints are vital. Index structures, and also various query transformations or hints that just don't make sense. And never forget, your DBA may have simply decided to disable hints by setting these. So to conclude, the approach I take is to use hints as a discovery tool in development all the time. In production, very, very rarely necessary. And if you do use them, document them so you can keep revisiting them with every upgrade. And the way I think of it, because this is my history, when you first start programming with Oracle, you don't know what a hint is. Then you learn about them. Wow, I'm going to use hints. Fantastic. Then later on, you start removing them all because you find a better way. Back to you, Dave.
Thanks so much, John. I'd like to throw out one last question. I know we've gone over time here, folks, but this question is about statistics and you know, when should they update them? And the question is there a script to compare statistics to real counts to find the tables and index that need updating? Updating of stats, I mean, of course.
You're going to have to write your own, and you're not going to be able to automate it. The defaults using the auto task, you'll get your tables reanalyzed and histograms built up if histograms exist when, if I remember correctly, 10% of the table has changed. But then if you have a table with 1 billion rows, you can probably change 20–30% of the table, and it's not going to have any effect. Whereas if you have a table with only 100 rows, and the 10% of rows that have changed are perhaps all at the high level, above the high value of the previous set of stats, you know, maybe you should analyze much more frequently. Now, I can't see how you could really get an automatic mechanism. It's the mantra I chant that you have to understand your queries, you have to understand your data, and then make the decision.
I'd like to emphasize something you said, and maybe you could amplify yourself. There is brains built in to estimation in that it won't estimate everything. It only estimates tables and indexes that it thinks need estimating. As you said, I think the default's 10%, but that's changeable, right? So if you know your data well, you can set it appropriately.
That's correct. Yes, you have to understand your data and the queries that are hitting it.
Great. Thank you all to our attendees today for attending and listening and your questions. We appreciate it very much. We hope to see you in the class. John, to help you with a tuning project, tuning the database, tuning an application, tuning a query. You would be amazed at how fast we can get things done. John can get things done. And if you would like some mentoring, you would be amazed at how much you learn during that exercise. So thanks all very much. We hope to hear from you and see you soon. Have a great day. Signing off for now.